Assalamualaikum warahmatullahi wabarakatuh. This is Adib, your lecturer for statics, section 16 and 17. Now we go to chapter 9, center of gravity and centroid. Actually, after chapter 5, the previous chapter 5 on rigid body equilibrium, right? So we jump to chapter 9 straight away. Okay, so we go to center of gravity and centroid, and then we'll go to chapter 10 later, about the moment of inertia, and then we'll come back to chapter 6. Okay, we come back to chapter 6 on structural analysis. We skip chapter 7, it's not in your syllabus, in your course online. And then we'll go to chapter 8, the final one, which is the friction or dry friction, because you are going to cover the wet friction. That's it for your statics. Okay, so for center of gravity and centroid, actually probably you have some idea on center of gravity. So the objectives of this chapter for your syllabus is just two. There are only two objectives. First one is to understand these concepts. Okay, what are these concepts of center of gravity, center of mass, and centroid, right? And then the next one, the first one is in 9.1. okay, and the second one in 9.2, you need to apply this on the composite bodies. Okay, in 9.1, let me change it, pen. In 9.1, this is on a kind of one area only. Okay, something is wrong, right? But in 9.2, then you have composite bodies. For instance, you have a rectangle, and then suddenly you have another rectangle, and then you have a triangle, something like that. Okay, so this is composite body in 9.2. In 9.1, it will be just one area, one shape, right? Next, okay, so center of gravity, simply put, center of gravity, it will locate the resultant weight. Okay, for instance, if a center of gravity of a body is here, so basically the resultant weight will act on here. It doesn't mean that the weight will only act here. No, it doesn't mean like that. It means the resultant, okay, resultant weight will act on the center of gravity. Okay, that's why you need to determine the location of this center of gravity. Okay, so again, like I said, the resultant weight is actually the total weight of particles. Okay, for instance, this is a body. For instance, it has 4 particles. Okay, so the resultant of 1, 2, 3, 4 particles will be this WR. Okay, so it will be W1 plus W2 plus W3, something like that. I mean, of course, the particle will be very, very small. It won't have just 4 particles. Okay, and then another thing is the sum moment of weights of all the particles about x, y, and z axis will be equal to moment of resultant weight about this axis. So this is the sum of moments of weight of all the particles about x, y, and z axis, and will be the same like the moment, the m, moment of resultant weight about this axis. Okay, and center of mass, we will locate the resultant mass, right? So you have to understand the weight. Why we have weight? Because we are on the earth, right? If you go to the space, then there is no weight because there is no gravitational effect, right? But center of mass, then actually it does not it is the property of the mass of the body itself. Okay, and it won't change. I mean, as the body doesn't change, then the center of mass won't change, but center of gravity can be changed. Yeah? Okay, and then next we go to the concept of centroid. Centroid actually defines the geometric center. Okay, centroid defines geometric center of an object. Simply put, let's make some kind of primitive shapes like this rectangular area rectangle. The centroid will be in the middle, right? right? It is very straightforward, like a straight line. The centroid will be in the middle, something like that. It's very simple. And actually this primitive shapes, actually they are in your back cover, I think, or your appendix of statics book textbook, so you can check them out. Okay, and then for the triangular area, the centroid C here, it will be 1/3 from the big side here, 1/3. And this is 2/3 of the length of this height, right? And again, 1/3 from here and 2/3 from the smaller side. Okay, and for cylinder will be in the middle, simple as that. Okay, and for the quarter and semicircle arcs, so you can find it as like this. Okay, 2r over pi. Okay, okay, for clearer picture you can go back to the textbook, you can find that. Okay, the centroid of this semicircle or quarter circle, right? Then we have talked about center of mass. Okay, then go to center of volume. So basically, if you have a homogeneous material, right? So your center of mass and so center of volume will be the same. Okay, because what's the relation between mass and volume? It is mass m equals to rho times v, right? The mass density rho times the v. V is the volume. So if you have a constant rho, so your mass and the volume are directly related, right? Okay, so for centroid of a volume, basically the equations are given like this. For instance, you have a body, this blue one, okay, the body, and you take the any volume here, and then you want to find the centroid. Okay, you want to find the centroid C, is given as this, the x location, x bar. For the y location, the y coordinate is given like this, the z coordinate will be given like this. So it is integration of volume of x till there dv over integration over the volume, right? And then the same goes to y and z. Okay, it will be clearer when we do the examples. All right, center of an area, same. Okay, will be most of the questions will be from the center of the area. Okay, so here there are some steps we're going to discuss. We have to make a differential element like this, dA, right? And then the equations are given same like before. Okay, this is your area, and then this is your centroid C, and then you want to find the x bar and y bar, the location of the centroid. So the x bar and y bar is given as this, integration over the area of x till delay and integration over the area, right? Line again the same. It's just you change the A with the L, right? So if you realize, actually center of a volume, it was dV, center of an area, it was the A, and now center of a line is the L. Okay, integration over the L. Of course, when we do the examples, then I mean the theoretical problems will be different from one another, but the general idea is quite simple actually, right? Even in this, the L, actually the L, you can use Pythagoras theorem to express this dl in terms of dx and dy. Okay, steps to determine the centroid of an area. Okay, for area, okay, centroid of an area. Choose differential element A, dA, sorry, at the general point x, xy, and then you have to after you have chosen the differential element dA, you have to express this in terms of dx or dy, right? Then you have to determine the coordinates of the centroid x, xy of the rectangular element. Rectangular element is this differential element. Okay, and then you express all this in the formula, and then you integrate to find the x bar, y bar, or even z bar, right? Okay, example. I'll go through this example very briefly. All right. So the question asks, you have this shaded area, right? So the question asks to find the centroid. And actually this question has, so for instance, this is the centroid, so this is the x bar, right? And this is the y bar. That's the idea, right? Okay, so your x bar will will use this formula, your y bar will use the formula, right? And this curve, it is given as this function y equals to x cubic. Okay, and then the x and y axis system for the system is given. So you introduce this differential element dA, right? And then you express them. I mean, you have to give dimension. This is x, this is dy, isn't it? You cannot say this is y, this is dy. This is dy, the thickness. This is x, it's fine because this is y equals to x power of 3, right? And then the centroid will be here. The centroid of x will be x over 2, right? While the centroid of y will be y itself, isn't it? Okay, because this is your 0, 0. So this is x over 2. And this one goes y. So have you understand this, and then you express the a in terms of x dy, and then you put everything into the x bar prime and y bar prime, and then you will get the answers. Okay, so the x bar prime is 0.4 from the left, and then y bar prime is somewhere 0.57 from the bottom, right? Same goes to this example. I mean, we'll go into the more on the details on the when we do the tutorial, right? The center of the shaded area, again same, but now we have another area. Previously it was the white area, now it is the other region, the rest of the region. Okay, the remaining region. And you have to choose this differential area accordingly, right? Like this, and then you apply the same steps, and then you got this location. Okay, x bar prime and y bar prime. Okay, 9.3 again, can go through that, and inshallah I'll do the tutorial on this. Okay, and that's the first part, which is just a simple composite simple area. Now we go to the composite areas. So composite bodies, what does it mean by composite bodies? It consists of a series of connected, simpler shaped bodies which may be rectangular or triangular or semicircular. So what happens is that for composite parts, you can section into smaller parts, right? And it is accounting for a finite number of, for instance, just a quick one. This it's not clear. Pointer, eraser, take back. Okay. Pointer, pen. Right. For instance, this one, right? Can you see that actually this composite part, if you break into smaller or simpler shapes, it will be this triangle, this triangle C, and this rectangle B, right? And then on the left side you have the semicircle A, like that, with the radius A, right? And then there's a hole of radius D. Can you see that? So this is composite part. I mean, you even for this kind of divider on the road, this divider, you can divide into smaller smaller simpler shapes, like the one in the middle as this one rectangle, right? And then a little bit of triangle, and then rectangle at the bottom, right? So composite bodies, you can break them into smaller or simpler shapes. So the procedure for analysis it will be easier when we do the example. Okay, divide into finite number of composite parts that we have simpler shapes. Okay, and bear in mind the whole you have to consider as an additional composite with negative weight. I mean, we'll subtract the whole letter. If you have the whole, you will subtract in the equation later. Okay, and you have to establish the coordinate system, and then you do this summation, and then we'll see the centroid of these objects. Okay, for instance, very simple one, wire. Can you see that actually this wire is bent into 3 parts, right? From the origin 0 0, you have this length 300 millimeter, right? And then you have 600 millimeter length, and then you have 400 millimeter length. So actually you have the first one, second one, and the third one, the third part, right? So in the solution, okay, because you know that the formula to find the centroid for the whole composite body is x bar is this, y bar is that, and z bar is that. So simple, you just have to find what is x tilde, what is the line here. So you have 3 parts again. The first part is A or 1, whatever. The blue one, A, B, the orange one, green one is C, right? So you table them up. The length individually 300, 600, and 400 millimeter, right? And then the x, what the location of the centroid in x, the x coordinate of the centroid for each part. So this is 150, right? And this is 300, right, for x, and this is 300 for x, right? And then you can excuse me, you can multiply them xl, because that's what will happen here. When you want to find the x bar, you need to have the summation of f of xl. Okay, you sum them up, okay, and you have this column, and then you proceed with the y now. For instance, this one, for A, segment A, the y is 0, right? The y is 0. For B, the y is how much? Somewhere here. It is 300, because it's in the middle of 600, right? And then for C, the y is 600, right? Because it's somewhere here, and here, the location. It's not somewhere there. I mean, it's there, because you know, for a uniform body like that, for a line, for instance, the centroid will be in the middle, right? Okay, Z. What about Z? For A, the Z will be 0, right? For B, the Z will be 0. For C, the Z will be minus 200. See, minus 200. Okay, and then you multiply with Z with L. Okay, and then you put into the equations. Okay, sum them up. See, you sum XL, you sum YL, you sum ZL, and then you get X bar, Y bar, Z bar. Which means that, what does it mean by that? It means X bar is 265 somewhere here, Y bar equal to 200 somewhere here, and Z bar equals to minus 61.5, which is somewhere there. Okay, so this is the location. Can you see that actually this location, the location of this composite body for this bended wire, actually is not on the wire itself, right? So actually it can happen. The location of the centroid is not on the body itself. For instance, a ring, wedding ring or whatever, the centroid will be in the middle, but it's not on the body, right? It's on your finger if you wear that one. Okay. Okay, next, centroid of this cross-sectional area of this beam, the T shape. Okay, the centroid Y. First thing first, can you see that actually the location of the centroid, the X bar is 0. You know that. Why? Because it's here. It will be somewhere along this y-axis, right? Somewhere along the y-axis. Okay, for X bar. But for Y, then you have to find. So for Y bar, again, because it's a composite part, you can break into simpler shapes. Shape A and shape B. Shape A is this rectangle, okay, 150, 300 millimeter, and the thickness is 50 millimeter. And then for B, the base is 50 millimeter, the height is 300 millimeter. So same procedure, because you will start from x00, xy here at the bottom here. Okay, so for B, for A, let's start with A. the centroid will be in the middle between 50, right? It will be 25 here plus 300, so it will be 325. The y for A. For B, it will be straightforward because this is 300, the line is 300, so it will be half of that, which is 150. Okay, the area, okay, I don't want to talk about the area, you can find it yourself. It's very simple with rectangular shape. You have the area, you have the y, you multiply them and then sum them up, okay, and then put into the equation, and this is your 237.5 millimeter, which means that it is somewhere here, right? This, so this is your y bar, 237.5 millimeter. Okay, this beam cross section, again, you can do that two ways here. Two ways. One is you consider A, B, and C individually, the three parts of them, okay, and sum them up. Or you consider A as the whole section, cross section, and you subtract B, right? You can do that as well. So try to look at this example and how to construct this table. This actually, it needs practices. So you need to do this table and all this calculation. Don't just look at them and think that you can do that. It's not enough. Trust me. You need to do this step by step. Use your own calculator. Use your own pen and paper. Sorry, to write this out. Right. Okay, and then centroid of this. Again, this is an example that the centroid will be outside the body itself, right? So you have this kind of L shape, okay, of whatever, probably it's a beam. And then you can find the centroid. You can break into two parts, A and B, right? And then do this those procedures, and you can find your X bar and Y bar. Or again, another one is you can consider A as the whole triangle with 3x4 triangle, right? And then you subtract B, which is the one which is not the area, okay? The area will be negative here. See, the area of the B will be negative. And then you will sum them up, and then you will get exactly the same answer, okay? Okay, more examples. Some of these examples will be in the tutorial videos, so check out on the tutorial videos. I'll solve them up, okay? Okay, probably I'll do this the solution for this as well, because now you have this quarter, circle, and semicircle. So you have the kind of specific formula. Actually, is in the back cover of your not back cover, the back pages of your statistics textbook. You can find them up, the location of the centroid for this quarter, circle, and semicircle. Okay, that's the end of chapter 9. Good luck, and we'll go to tutorial videos for the chapter 9. And then we go to chapter 10. Okay, Assalamualaikum.